Hello and welcome back everyone. This is Noah, and in this video we're going to look at how to find x-intercepts given a difference of squares quadratic function. Alright, so we've got these examples we're going to look at to start. We want to find the x-intercepts of the following quadratic functions, which are all differences of squares. So we need to talk about what is that, how do we recognize it, and how do we use that to our advantage in finding the x-intercepts for these specific functions. I want to create a little bit more space for myself here. No. This software makes me so angry sometimes. There we go. Oh, and it still did it. There we go. Okay. So the first function we're going to look at is f of x equals x squared minus 9. So our goal is to factor this. Now it's a little weird because the middle term is missing. So I'm going to start by just saying 0 equals x squared minus 9. And what I want to recognize is that x squared is a perfect square. It is some number squared. A nice x value, right? So is 9. 9 equals 3 squared. So it is a perfect square because it's a nice whole number squared. When we have this situation, then we can look at factoring this in the same way every time. We'll have that first number, right? The x needs to go in the beginning of both of these. And then we want to think the 9, we want to put a 3 and a 3 here so that those multiply to be 9. And what we do is we put a plus and a minus. So this is going to be how all of these work in this really nice way. If both of these are perfect squares, we can do this with a plus and a minus here, because what happens is if we FOILed this, we would get x squared minus 3x plus 3x minus 9. And so by having these be the same but opposite signs, the middle terms would cancel out back to x squared minus 9. So this is a really handy thing to recognize to be able to factor these quickly. This then allows us to see that x plus 3 equals 0 or x minus 3 equals 0. So x equals negative 3 or x equals positive 3. So my x-intercepts are the points negative 3, 0 and 3, 0. It's not so bad, right? Let's do this again for part B. We want to find the x-intercepts. So we set this to 0. 0 equals 16 minus x squared. And we want to factor this. So we'll say parentheses, parentheses, two sets of parentheses being multiplied. The 16 is 4 squared. So if I put a 4 and a 4, and then an x, and I do a plus and a minus, then when we FOIL this, so normally I wouldn't write this part on the right, but just to show that this works, once again, we would get 16 minus 4x plus 4x minus x squared. And the middle terms would cancel to be 16 minus x squared, just like we want. So from this, I can see that 4 plus x equals 0, or 4 minus x equals 0. Solving for x, we get x equals negative 4, or x equals positive 4. So the x-intercepts are the points negative 4, 0 and 4, 0. Isn't that kind of nice? Just being able to see those perfect squares. See, they get a little bit more as our functions. I set this to 0. 0 equals 9x squared minus 1. And we look and notice that the 9x squared, that is a perfect square. That can be a 3x. And then we'll put a 3x in the beginning of the next one. And then 1 is a perfect square because 1 times 1 is 1. And if I do a plus and a minus, then this should all work out, because if I FOIL this, we'll get a 9x squared minus 3x plus 3x minus 1, and the middle terms would cancel again. So we get 3x plus 1 equals 0, or 3x minus 1 equals 0. Solving for x here, we get x equals negative 1/3, or x equals positive 1/3. We see that these are the same but opposite signs here. So with this, we write our x-intercepts are the points negative 1/3, 0, and positive 1/3, 0. All right, one more example that we're going to look at. K of x equals 9 minus 25x squared. Set this to 0. 0 equals 9 minus 25x squared. We look to factor this. We get 0 equals 2 sets of parentheses. We see a 9 and the 25x squared. These are both perfect squares. So the square root of 9 is 3. That goes in the first positions. Square root of 25 is 5, but we also need the x there. So we'll have 5x in the second positions with a plus and a minus. You can see that this should FOIL out as, if we FOILed this, we would get a 9, and then we would get a minus 15x and a plus 15x, and then a minus 25x squared. The middle terms would cancel, giving us a 9 minus 25x squared, just like we want. So this works. So we have 3 plus 5x equals 0, or 3 minus 5x equals 0. Solving for x, we'll get x equals negative 3 over 5, or, let's do this one in a couple steps. We'll get negative 5x equals negative 3, divide by negative 5 to get x equals positive 3/5. The negatives cancel there. So our x-intercepts are the points negative 3/5, comma 0, and positive 3/5, comma 0. So that hopefully you see that there's not a whole lot to this. It's kind of nice. You just have to be able to recognize that it's a difference of two perfect squares. It only works if there's a subtraction. As long as we're doing explanations here and examples, I will note, like if we had x squared plus 9, then this doesn't factor. If we try, we would want an x and an x in the first positions. And we could try a 3 and a 3, but if we did plus and plus, then we would end up with this being x squared plus 3x plus 3x plus 9, and that would be x squared plus 6x plus 9. And so that 6x is not correct. If we tried a minus 3 and a minus 3 in the second positions, we'd get x squared minus 3x minus 3x plus 9, and that would give us x squared minus 6x plus 9. And so again, that minus 6x is not correct. And if we do a plus and a minus, then that's going to give us the x squared minus 9. The middle terms will cancel out. So again, none of these work, and so x squared plus 9 is prime. It does not factor. Try as we might. Okay, so that's just to note that it has to be a difference. Does not work with a plus. Go ahead and look at the Now You Try problems. Give those a go, and in the next video, we'll walk through those solutions. Thanks so much. See you in the next one.